Well, good morning. Welcome to the Premium Public Video Forecast discussion for Thursday, January 18th, 2024. And we have a lot to talk about with a impactful snowfall expected for central southern New Jersey and the Philadelphia metro. New York City metro, you'll get some light snow, but I think you'll miss the brunt of this storm. So I just wanted to touch on what we can expect as far as updates moving forward. Okay. So obviously we have all the morning updates and the video discussion that will be out. And then this afternoon, evening, we'll have additional updates, see if we need to tweak anything before the storm actually gets going. And then tomorrow, we'll have our hourly updates starting at 6 a.m. and continuing all the way through until the storm's over or I pass out, whichever. But this is going to be a very interesting event because it's going to be driven by mesoscale dynamics, which can be very, very difficult to forecast. So it doesn't surprise me one bit that we're seeing a lot of changing forecasts out there. You might see on social media, from the National Weather Service to media outlets to my forecast, which has been out since Tuesday for premium members and has been pretty consistent in what I've been expecting. So the public map that was sent out only had some minor changes from what premium members have been looking at. So let's dive into the data and we'll walk through everything and explain the forecast so that way you can be prepared as we move forward. So let's dive into this. So today, right now, we have Arctic air in place with temperatures ranging from the single digits in the Catskills and Poconos to the mid 20s in your urban areas. Winds are generally light and variable. On the radar, we have some signs of snow, but this pretty much is not reaching the ground. We have a lot of dry air in place, but today will feature just the potential for some flurries and some weak snow showers, maybe a dusting here and there, but nothing really significant. This is driven by the frontogenesis here at 850 millibars, by this shortwave. This shortwave back here, rather dynamic one at that, is what's going to be interacting with this frontogenical area, this area of thermal gradient that is going to support the stretching of the atmosphere. It's one of the features. When we take a look at the latest infrared satellite picture, you can see lifting motion already starting to developing here. Some cold cloud tops already developing here. The only inhibiting factor is dry air at roughly 925 to 700 millibars. So as a result, anything that falls out of these clouds is having a difficult time getting down to the surface, which is why we're not seeing widespread snowfall being reported. As we go back to the observations, pretty much just a lot of cloudy skies, no signs of any snow flurries or any type of snow report anywhere in the region while we continue to have these clouds moving through. This is the disturbance back here that is going to be creating some mischief. Now, and take a look at the frontogenesis 700 millibars. I want you to get used to this because this is going to be a indicator of where we're going to start to see our inverted trough driving this pattern, driving this snowfall for central southern New Jersey and southeastern Pennsylvania. This morning, we can see the frontogenesis helping to support some very weak lifting and the support of those elevated snow showers and possibly some snow flurries. But again, it's not really organized compared to what we're seeing here and here, which is kind of in its infancy. On our upper level winds, we have the block. Okay, you have a nice upper level low over southeastern Canada. You have a block building into Greenland. You have your broad trough. Here's your subtropical jet stream. Why are we not seeing a widespread winter storm that will impact the entire I-95 corridor from Boston down to Baltimore? Well, it's because of this ridge axis here. You see, remember what I was saying for the past couple of storms, and this one especially, ridge axis matters in this scenario. A lot of things matter, depending on the evolution of the Pacific, evolution of the Atlantic. In this case, because this ridge is right here on the west coast, it makes this trough much broader. Okay. And so with a broad trough, you don't have the best timing with the subtropical jet stream. So the short waves are missing out, and there isn't enough time to create a full phase and allow a storm to track up towards, let's say, Cape Cod or locations or around 40 north, 40 north to 70 west, right around here, which is our benchmark. Instead, you end up with the scenario where a low pressure system intensifies out to Delmarva, but rapidly heads out into the Atlantic. If this ridge axis was here, then you'd get a sharper trough here and a better chance for what we call a negatively tilted trough, where the trough is a line like this. But in this scenario, you end up with a positively tilted trough, but the trough kind of lags off to the southwest. And that's what helps create the scenario of this heavy snow band. So you can see that pretty nicely here on the water vapor satellite picture. There is our block. Okay, this is what's keeping the cold air in place. Here's our short waves running under the block. Here's our subtropical jet stream down here, which will funnel in a little bit of moisture, but not really reach its full potential here in this scenario because our ridge is out here rather than here. So we got that laid down. Now, the next question in driving this weather pattern, we talked about this last night in the live chat, is the location of this jet streak Friday morning into Friday afternoon. And the progression of this jet streak supports the strongest lifting over the New Jersey coast back through southeastern Pennsylvania around the Delmarva Peninsula. So right around here. You don't have that type of support up towards New York City and Long Island, but it's enough to create light snowfall. Okay, so there's enough lifting here, enough jet dynamics to support snowfall in the New York City metro back to the Poconos, but your best dynamics is down here. The next feature we want to look at is the lifting. Okay, so here we are, 500 millibars. This feature right here is what causes pulling and stretching in the atmosphere. So here we are at 30 hours out, which is around 1 a.m. tonight. You can see the lifting starting to develop here, and this would support the development of snow showers and some light snow. As we head towards the morning hours tomorrow, that lifting intensifies. The trough approaches the Ohio River Valley. You're seeing increased lifting at the mid-levels starting to organize itself. Towards the afternoon hours, the trough approaches the northern mid-Atlantic. You can see the lifting intensify at 700 millibars. Notice this feature right here. Again, now this is synoptic model, so we don't have as great of resolution compared to mesoscale models, which we'll take a look at in a moment. But you can see this lifting signal right here. And at 850 millibars, you can see that starting to develop very nicely here around the southern mid-Atlantic. And you can see that positively tilted trough influence as well. That's stretching in the atmosphere. So you have the stretching in the atmosphere here, and you got your stretching in the atmosphere all the way up to 500 millibars. So once we get to the evening hours, the trough finally reaches the northern mid-Atlantic. We have strong lifting at 700 millibars just off the coast, and strong lifting at 850 millibars, clearly setting up from Long Island down through Baltimore. Okay. Now, again, what you want to do in this scenario is use mesoscale models when judging a lot of the lifting parameters here. In terms of the temperatures, 850 and 925 millibar temperatures are going to be very chilly. Okay, so one of the things I like to look at in the afternoon during the afternoon hours tomorrow is this gradient right here. And this is gradient, usually when you have a gradient between -6 and -8 degrees Celsius in this area here, right around that gradient is typically where you see your heaviest snowfall. Okay, so that's pretty much setting up right around central and southern New Jersey back through Philadelphia. Everyone's going to see snowfall, but there's also that hint of a mix. Now, it's difficult to see that at 925 millibars, understandably. You take a look at it and you're saying, well, it should be all snow event for everybody. But at the very surface, along the immediate coast, let's say the Barrier Islands of New Jersey, that's where we'll see a little bit of sleet and rain mixing in. Not a complete change over to rain, but some snow and sleet mixing in from time to time as this precipitation continues to evolve. Part of this is because the stronger bands that are going to set up just inland are going to create some substance and sinking and warming of the atmosphere, and that's going to allow for more mixing. We'll touch on that in just a moment. Then here we are with the moisture transport. Again, clearly a focus towards the Jersey Shore here, a little bit lower as you head northward in this scenario. And then you can see the rapid end of the storm in the evening hours as the dry air pushes southward and crushes the band to the south. So this is the European guidance here. You can see the general idea, pretty well supported. General, the idea is pretty much locked in. Now, when you're looking at these snow maps, understand one very important thing. One, 10 to 1 ratio. We're going to be dealing with more than a 10 to 1 ratio in this scenario. And two, it's showing the potential for banding, but it doesn't do a good job of handling it. This is where you want to use mesoscale models. Again, when you're dealing with snow banding, it's a mesoscale question. It's a mesoscale problem. So when you have a mesoscale problem and a mesoscale question, you have to use mesoscale models to create a mesoscale answer, right? Makes sense. So this is where the NAM and HRR come in handy. Okay, so here's the NAM guidance, and you can see the evolution of the storm. You see the idea of mixing here. Now, this around the Jersey Shore, we're talking about 33 rain snow mix. I don't think this goes fully over the rain, but you're just going to get the kind of a little bit of a wintry mix of snow, sleet, and rain in those areas. It's going to hold down accumulation a little bit. Notice the intensity of the snowfall here gets lighter here. And then you can see as that band intensifies, the entire snow shield breaks up as that snow band reaches peak intensity and then drops to the south. So impact times look like, again, starting around midnight, you'll start to see some snow showers and flurries becoming steady by the morning, heavy as you head towards the late morning and afternoon hours, and then swinging out in the evening. Obviously, taking a longer time as you head towards central southern New Jersey because the band's going to last longer and they are same thing in southeastern Pennsylvania. Don't want to forget those guys. On the HRR guidance, very similar. HRR guidance has a little bit better fine tuning on this type of convective pattern here. And again, you can see the very intense band here. Now you're going to have sinking air to the north and to the south. So you get this suppression of snowfall here and lighter snowfall here. Okay, so your ratios are going to be 15 to 1, but there isn't going to be a lot of moisture. And you get this light snow all day around the New York City metro, pushing 1 to 3 inches pretty easily, as you can see here in the guidance. Now, again, we have this signature here, 4 or 5 inches of snow. I am concerned about pushing as high as 8 inches in this scenario with some of these bands. And the reason why is because of what I'm seeing here in the skew T. This is a sign of convective snowfall, like thunder snow. So I'm rather concerned that we're going to see a band produce a very intense heavy burst and reduce visibility below 2 miles, maybe below a mile, in locations like central, southern New Jersey and southeastern Pennsylvania, somewhere in this ballpark here. And so that takes us to our forecast. Okay, further north, trace to 2 inches of snow, Connecticut, Hudson River Valley, up to Boston. Just snow showers, very light snow. Down towards the New York City Metro, Long Island, back through northeastern Pennsylvania. This is where I think you'll see steady light snow. I think a lot of locations are going to be in the 2 to 3 inch area here. Don't be surprised by that. And then this is where things get a little tricky. Okay, now in this area here, back through, let's say, York, PA, down through northern Delaware and northern Maryland, this is where I have 2 to 5 inches of snow. Somebody is going to get limited snowfall because there's going to be so much intense lifting here. There's going to be sinking air somewhere in this area here. So that's why there's a nice little gradient here between some locations getting 2 inches and most locations getting that 4 or 5 inches. So that's why we have that basic range here. Back here, this is via orographic lifting. If you're traveling out towards the West Virginia mountains, that's where you get 4 to 8 inches. Then we get to the banding area. A lot of locations, again, we're going to start at 12 a.m. From 10 a.m. to 6 p.m. is where I'm expecting those bands really to fire. Most locations around here are going to be at 4 to 5 inch mark. So don't be surprised if Philadelphia and Lancaster end up with about the same amount, 4 and 5. But wherever that band sets up, wherever those bands, plural, bands set up and rotate through, that's where you're going to be able to push over that 5-inch mark and get 6, 7, 8 inches of snow, because your snowfall rates are going to be easily 1 to 2 inches per hour while they're dropping through. So this is where that threat is the highest. And then along the immediate Jersey Shore, in fact, as a premium member, you can zoom in to exactly where you're at and take a look at this setup here. And basically, right around here, you're going to have that snow, rain, sleet mix at times. I would not be surprised if you have a scenario where the immediate coast of Atlantic City gets 1 inch, but then just inland Pleasantville gets 4 inches. So I would not be surprised by that scenario at all. I wouldn't be surprised if Long Beach gets 1 inch, Little Egg Harbor gets 4 inches. It's going to be that tight of a gradient. So that's what we're looking at in that scenario. So again, the worst impacts are going to be late tomorrow morning on through the afternoon hours. So if you have any travel plans tomorrow during those time periods, use extreme caution, because visibility is going to be poor and the roadways around here aren't exactly the best to begin with all the past freezing rain and sleet and snow from earlier on in the week. So just to dive into the rest of the forecast for today, sky cloud cover with a few snow flurries here and there. Look for high temperatures in the mid to upper 20s over the interior, lower to mid 30s along the coast. For tonight into tomorrow morning, snow showers begin to develop towards morning. Look for low temperatures to range from the upper teens to lower 20s over the interior, mid to upper 20s along the coast. Tomorrow, periods of snow, heavy at times along the Jersey Shore back through the Philadelphia metro. Look for high temperatures ranging from the mid to upper 20s over the northern interior, upper 20s to lower 30s along the coast. For Saturday, the storm pulls away with lingering snow showers here and there. Look for low temperatures in the single digits to mid-teens. High temperatures will range from the mid to upper teens over the northern interior, lower to mid-20s along the coast. On Sunday, high pressure will be in control with tranquil conditions. Could be a few snow showers out here for the Chiefs-Bills games. We'll have to watch that. But other than that, look for sky cloud cover around our neck of the woods, with low temperatures ranging from the lower to mid teens and high temperatures ranging from the lower to mid 20s over the northern interior, upper 20s to lower 30s along the coast. On Monday, we begin to warm up with sky cloud cover expected. Still chilly in the morning with lows in the single digits to mid teens. High temperatures, though, will range from the lower to mid 30s throughout the region. On Tuesday, a warm front will lift through the region with some rain and snow for the northern interior, a few showers over the rest of the region, with temperatures ranging from the lower to mid 30s for lows and high temperatures ranging from the upper 30s to lower 40s over the northern interior, lower to mid 40s along the coast. So by Tuesday, we'll start to see a pretty significant melting throughout the region of all the snow and ice. On Wednesday, it gets warmer, with the threat for scattered showers becoming more widespread towards the evening hours. Look for low temperatures in the lower to mid 30s and high temperatures ranging from the upper 30s to lower 40s throughout the region. On Thursday, sky cloud cover with a few showers towards the afternoon and evening hours are expected, with low temperatures ranging from the lower to mid 30s and high temperatures ranging from the upper 40s to lower 50s over the northern interior and lower to mid 50s along the coast. That is your forecast discussion for today. Again, the idea here is that this storm is going to be something that, with these bands, there's going to be some localized areas where visibility is going to be very poor. We'll continue to watch this storm evolve as we move on. And of course, we'll have updates throughout the day tomorrow, every hour, much like the previous storm. So we'll be able to keep you guys safe and well informed as the storm evolves. In the meantime, stay safe out there.